This is a video tutorial for the CloudBD All-in-One. The CloudBD All-in-One is a really easy way to try out CloudBD disks in AWS. It's a CloudFormation template that creates an isolated VPC with an EC2 instance that comes with a CloudBD disk pre-attached and ready for testing. CloudBD disks are an alternative to Amazon's EBS volumes, except CloudBD disks are much higher performance. They support up to 2.5 gigabytes per second of throughput. They have much higher data durability, as all of the data is backed by S3, and a lower cost per gigabyte of storage. So there's a couple of prerequisites to this guide. So first we're going to cover the setup of the all-in-one, and then we're going to go ahead and SSH to the instance once it's created and do a couple of example performance tests. But the prerequisites are you're going to need an AWS account with the necessary permissions to create the stack, as well as a pre-existing EC2 key pair in the region so that you can SSH to the instance. So it's probably good to also have the AWS console open in another tab. So on my AWS console, you can see I already have a EC2 key pair ready to go. If you're interested in following along with this video tutorial yourself, you can get to this documentation by going to the CloudBD homepage, selecting documentation, and down to the AWS Quick Start. So the setup of the CloudBD All-in-One is pretty simple. You're going to need a free CloudBD account. So if you go to the manage.cloudbd.io/signup, you can create a username. All it requires is an email, and when you sign up, you'll get a confirmation email to make sure the email is valid. Follow the link, and then you can log in. Once you've logged in, you'll see the CloudBD management dashboard, and you can select the credentials page. You're going to need to get a copy of your CloudBD credentials for the all-in-one. So step 1, sign up. Step 2, navigate to the credentials page and get a copy of your CloudBD credentials. And step 3, we're going to take that CloudBD credentials and upload it to the AWS SSM parameter store. Let's see if I can just open it. Okay. So we're just going to select this whole JSON blob and copy it, and then come into the Systems Manager on AWS. And find the parameter store. And I've already created the CloudBD credentials parameter on this account, but if you follow the tutorial, you'll be selecting create parameter, entering CloudBD credentials.json, secure string to encrypt the parameters, and paste your credentials into the value. You can select a customer managed KMS key to encrypt them, or you can use the default Amazon provided key for SSM. So just a quick, what are the credentials? The credentials are kind of like a software license for your CloudBD account. You're going to require a copy of them deployed on your EC2 servers. And by providing a copy of your credentials to the SSM parameter store, it makes it really easy to securely deploy to your EC2 servers as part of the CloudFormation deployment. So if we come back to the Quick Start guide, we've done steps 1, 2, and 3. And the final step is just to create the CloudBD all-in-one stack using CloudFormation. So I'm going to switch back to the Amazon console, go over to CloudFormation, and we'll create a new stack. So you can select or specify an S3 URL for your template, or you can download a local copy and upload the template file. CloudBD does provide a publicly available S3 URL for the all-in-one, so we're just going to use that one. It's also available on our GitHub project page. And this is also publicly available, where you can take a look at the history of the all-in-one template and see exactly what's in it. So coming back to CloudFormation, I'm going to paste the S3 URL and select Next. We'll give our all-in-one stack a name, just call it the all-in-one. So the parameters for this template are split into two sections. There's the CloudBD S3 remote parameters, and there's the VPC EC2 instance parameters. For the S3 remote, we need to select the AWS region where the CloudBD credentials parameter is stored. So I stored mine in the US East 2 Ohio region, and you have to enter the SSM parameter name. So our recommended parameter name is just /cloudbd/credentials.json. If you do select to use a customer managed KMS key, you'll need to specify the key ID. If you're using the default alias AWS SSM key, then you can leave this customer key blank. There's also a couple of optional parameters to enable server-side encryption on the S3 bucket that stores the CloudBD disk data. And you can enable HTTPS support for communicating between the EC2 instance and S3. This is optional. If you're using HTTPS, all of the traffic between your EC2 instance to the S3 bucket for your CloudBD disks will be encrypted, but it will use a little bit more CPU on the instance. And then for the VPC EC2 parameters, you select the availability zone, the instance type. I think we'll use the 4x large today, and the key pair. So this is the key pair that'll let you SSH to the EC2 instance, and then optionally you can restrict the IP address range allowed to SSH to the instance. So once you've selected your parameters, hit Next. You can add a tag or any special stack policies here. They're optional. And then we're going to review the template. So everything here looks good. And if you scroll all the way down to the bottom, the CloudBD All-in-One does create an IAM managed policy for providing access to the S3 bucket to the EC2 instance. So you'll have to acknowledge that it will create an IAM resource and create stack. So while this stack is creating, this usually takes between 3 and 5 minutes to create the full stack. We'll take a look at the actual template. So we'll open it up on GitHub. It's a little nicer syntax formatting. So this is the actual all-in-one template that we'll be creating today. The parameters section we already covered. Jump down to the AMI IDs. These are the Ubuntu Bionic 1804 AMI IDs provided by Canonical, and we'll periodically update these to the latest version. A couple of conditions for managing whether to use server-side encryption, as well as whether to enable the driver high-performance mode. This is mostly dependent on whether the instance type chosen has 25 gigabit networking. And then the resources used by the template. We have a S3 bucket with optional encryption for storing the CloudBD disk data, an IAM managed policy that provides access to the SSM parameter that stores the CloudBD credentials, as well as access to the CloudBD disk data bucket. And then CloudBD disks can be created directly from within CloudFormation templates as a custom resource. And to do that, you need a custom resource Lambda handler. So we have this CloudBD disk Lambda role that provides the CloudBD remote policy, as well as the ability to create log events to a Lambda, and then the CloudBD disk Lambda, which can handle creating and deleting CloudBD disks. The all-in-one testing environment is a single subnet VPC with the S3 endpoint for optimization. So we're just going to create a single subnet in a VPC with an internet gateway attached. And then the S3 endpoint allows for private routing between the EC2 instances and S3. And this is required for getting extremely high performance between EC2 instances and S3. We're going to enable SSH access to the instance. And then the last part of the template is the CloudBD test disk and the test server. So here we're creating a CloudBD disk using the CloudBD disk lambda defined above. We're giving our disk a name and a size of 128 gigabytes here. The EC2 instance is going to need access to the CloudBD disk data bucket, as well as the CloudBD credentials in order to attach the disk to the instance. So we're going to create a role, an IAM role for the test server. And in that role, we're going to provide the CloudBD remote policy. And then we're going to attach that role to the test server through an instance profile. The rest of the CloudFormation template is simply CloudFormation init scripts to, well, the user data is going to install Amazon's CloudFormation Bootstrap package so that you can use CloudFormation init and signal CloudFormation when it's complete. And then the metadata for the CloudFormation init describes how to actually install the CloudBD disk driver, as well as deploy your credentials from the SSM parameter store, attach the remote bucket and your selected protocol to the instance, attach the CloudBD disk to the instance, format the file system. So we're going to put an ext4 file system on the CloudBD disk, and we're going to mount it at /mount. And then lastly, the CloudFormation All-in-One template provides FIO, which is a file system and block device testing utility that's very customizable, and will provide several just basic test cases for you to try out. You can also customize and write your own test cases, of course. But we've provided sequential write, sequential read, mixed read-write, random write, random read, and random read-write. And that's it for the CloudBD All-in-One template. So if we come back to CloudFormation and take a look at our stacks, we see that the All-in-One is created complete. So we can come into EC2. And we should have one running instance. Here it is. This is our CloudBD All-in-One. So now we're going to connect to this instance. You can use either the public IP or the public DNS. When you SSH to the All-in-One template, or the All-in-One instance, it is a Ubuntu instance, so you'll need to SSH as the Ubuntu user. And just paste the public DNS or IP here. Okay, so when we first get on the instance, if we run df, we can see that we have our remote CloudBD All-in-One disk. It's mounted at /mount, and the disk size is 128 gigabytes. There's currently just the standard ext4 lost and found folder in the mount point. This is probably a good time to come take a look at S3. So our disk right now just has an empty file system on it. And here we see our S3 bucket for our All-in-One remote. And we see a single disk has been created, just a single small file. And then under the data path of the bucket, this is the disk UUID. You can see that there's should be some blocks for the file system already created. So there were 292 blocks allocated as part of creating the ext4 file system. And these are all fairly small. So coming back to the instance, the home directory of the Ubuntu user has the FIO test scripts. So we can run FIO with just, for example, the sequential write test, or it'll lay out 8 gigabytes of files. I'll write them, and here we see it wrote the 8 gigabytes at 2.1 gigabytes per second. So coming back to the S3 for a second, if I refresh this page, I think I originally had like 200 something objects. Now, since we have 8 gigabytes, there's a lot more data in the S3 bucket. So at this point, you can try out any performance tests that you're interested in or create your own use case for trying out the disk performance. If you come back to the AWS Management Console, come into CloudFormation, you can delete the CloudBD template or stack. And this will clean up all of your CloudBD disks, delete all the objects out of the bucket, and delete all the resources that were created. So yeah, I hope that this has been helpful in showcasing CloudBD disks, and if you're interested in trying them out, how easy it is to spin them up. If you have any questions, please feel free to reach out to us at support@cloudbd.io, and thank you for your time.